number of atoms. So in the question we are given atom, some chemical compound, and we have to return the elements that are present in the formula. If take the example of first one H2O, so we have 2 hydrogen and 1 oxygen, so 2H and O, that will be our answer. In the next one, MgOH whole 2, right? MgOH whole 2, alright. So magnesium, like magnesium, we have 1 only. Oxygen, we have 2, and hydrogen is like 1, right? So Mg1O2 and H1. So we have to return it in the ascending order. So H1, then will be Mg. 1 we don't write. And sorry, hydrogen is 2. So it will be H2, Mg, and finally O2. This will be our answer. There are few things, if you read through the question, you'll understand that few constraints are given. Like we won't write 1 anywhere. Like I just told you, 1 cannot be written. And these two are also valid if there is a parenthesis, Mg2. So this is also valid, and at the same time Mg2, and outside this is also valid. So these two are valid conditions. So before, rather than discussing the question, I'll just quickly jump to the solution. Prior that, let's understand two things. How are we going to extract the element, right? Because an element, if this is our case, MgOH whole 2, we have 3 elements. Mg is one element, O is one element, and H is also one element. So in short, our element starts with uppercase, right? And followed by any number of small, it's fine. Like for example, we can have Ca, uppercase followed by, so this considered as one element, right? If we get upper one and again upper letter, so these are actually 2 elements. And we have also one more possibility when we'll have one count on top of it. Let's say Mg2 or something O2H2. So uppercase can be followed by a digit also. So in order to identify, let's say forget about the parenthesis. If we only had this thing, Mg2O2H3. So how we were going to extract it? Let's say this was our question and we have to extract it and store it in our map. Okay, because we have to store a key value pair. This element will be my key and its count will be my key value pair. Okay, we have to store it in, let's say, in my map. This was our question. So how we were going to do it? It will be pretty straightforward, I think. We'll start iterating from it. Okay, we'll start iterating from it. And the moment we encounter a lowercase, I repeat, the moment we encounter a lowercase, we won't do anything because it will be associated with the previous uppercase, because all the elements has to start with an uppercase, right? So the moment we encounter any lowercase, we won't bother, right? So what we do, we'll start to iterate on it, right? We start to iterate on it. Let's say we start from this place. So I'll mark it as int, let's say n start equals to I. So our start is also pointing at this place. Now what I'll do, I'll start iteration from the I plus 1. So while I plus 1 is less than, or better do I plus plus here itself. And let's do I is less than, let's say its length is n, right? Length is n. So I is less than s, so no outer bound. And this is a lowercase. So if it's a lowercase, the character dot is lower case, right? Ch at I, if it's a lowercase, character at I. Okay, so what we'll do, we'll just increment our pointer. So I started from this place, it's a lowercase, so my pointer is sitting at this one now. So I is at 2, pointing at 2. So from this we can easily identify, right? We must have started with an uppercase, and now this loop has ended. There could be 2 possibilities. If let's say it was M only, and it has 2, and now it's at Mg2. So I was initially start was here. We start checking from the next one, I plus 1, right? So if it will be a 2 or it will be a letter, right? So if we got anything, my index, right? My I should be greater than start, right? If it's true. If I is greater than start, when we did found something, right? We did found something, and that becomes my that becomes our element. So string element will be nothing but s dot substring dot starts on or to I. Even if they are equal, so we'll just have one element, right? If they are equal, because anyway I've started from the I++. Nothing is there, then it will be at 0, it will be at 1, and if we found something, it will be 0, so we'll have 2 elements, and so on, right? So we got that element. Now our job is to find if it's pointing to a number. If not, then it's 1. So we have to calculate out the number. What's the count here, right? So again, we'll do very simple thing. While if again I will take a pointer, right? Start equals to I. It was mg2 o2 h3. My pointer is as here itself. Okay. So in this scenario, I'll check if it's a character. So I should less than equals to n, and is digit at I. If it's a digit, what will do? Will I++, let's say it was 22. So again, it will be digit, it will be I++, and it's still here, right? So again, from the start till I, will get our number. And if there was no number, we wouldn't have entered into this section. So again, we'll have a check if I is greater than start. Then we would have found our number, else number would have been 1. If we found our number, it will be what? It will be nothing but we'll have to change it to integer, right? And it will be nothing but s dot substring from start to I. That's how we'll get the count. And once we get the element, once we get the number count, we'll store it in the map. So map dot put element and the count, and we keep on doing it, and we'll get our answer. Again, so that's how we are going to solve in this question. But on top of it, we'll have parenthesis. So we'll have to include that scenario also. So when we start iterating on the question that they are given, input was mgoh whole 2. So we'll take a stack. It will store the map. That's the catch. Our stack will store the map, and we'll take a map at the beginning, right? So when we encounter anything apart from closing and opening bracket, we'll have 3 scenarios. When we encountered closing bracket, opening bracket, and closing bracket, or else part, right? When we start iterating on this one. So whenever we encountered anything, we'll try to extract the element and the count. So we'll extract the element and count, so we'll get mg, right? So I'll just put it mg and 1 inside my map, key value pair, right? The moment we get any opening bracket, we push it to the stack. So map 1 m1, this is m1, assume. So we push it back to the stack and created a new map. So new map was created m2, right? Now we got oh. So again, it will be extracted from the string oh, and we count will be 1. And we encountered a closing bracket. So the moment we encounter a closing bracket in this scenario, right, we'll try to see if we have any count. Whatever logic we have implemented in this one to calculate the number, right? We were using this while loop, right? We'll apply the same while loop when we encountered this one to get the count at the very end. Whatever count we'll have, we'll store it in multiplier. If there's no count, we'll assign it by default to 1. We'll get the multiplier, whatever multiplier we have received, right? And this is my current map, right? M2. So we'll just add, okay, right? In the case of OH, right, it won't be stored in 1, it will have something like this, because it's a different element, O1 and H1, right? And multiply 2, so we'll just multiply this map by 2. So multiplied by 2, multiply by 2, it will be 2 and 2. All right? So this is how we'll have everything, right? So the moment we encountered anything, we'll extract our multiplier, we'll multiply to the current map, and we pop out the previous map. I'll pop out the previous map M1, and I'll merge these two maps. Whatever M2 is present, I'll just push it in the M1. So it has Mg1 O2 H2 and we'll return this as an answer. Okay, let's try to revisit with a bigger example. K4 ON SO3 2 2. Start with a map. Okay, initially we'll have M1 map. So K4, it will be stored in map K4. Got a new one, so push it, create a new map. Okay, this part done, this part done, this part done. Now it's at O. Okay, so O1, it's at N, N1. Alright. Okay, got a new one, so push M2 inside the map. Or create a new map, M3. Now S1, O3. Then we encountered a closing one. The moment we encountered a closing one, right? What do? We get the multiplier if there is any. Get the multiplier if any, or make it default or defaulted to 1. Then multiply. My map was, we have over at M3 map. So multiply with the multiplier, the value section. So it will be multiplied. So we got 2. So we'll have S and 1 multiplied by 2 and O multiplied by 6. And then we pop it out. We pop M2 from it, our map, and we push these values into the map. We'll merge it. If the key is already there, we'll add the values. If not, then we'll simply add it to the map. So it already had O1, so O will become 7, N1, and finally S2. And this becomes, now this will be discarded and this becomes my current map. Alright, again I encountered a closing bracket. So we'll follow the same thing. We'll try to get the multiplier. I'll multiply it with the existing one. Okay. So it will be like 14, 2, and 4. And we'll pop it out M1 and we'll merge it. So M1 had K4, so basically it will have 4. So this will be our answer, K4. And oxygen is like 2. Here we have 6 oxygen and here we have 8. So 6 to 8, because we have to multiply it by 2, right? It will become 8 and so on. So that's how it will be done. Let's move to the coding. Alright, we'll take a stack to store our hash map. So it will store map, which will store the elements and its value, right? Stack, and then we have to take a map. The map, it will store the element and its count, the string, integer, and let's make its current map. Current map. And now we'll start iterating on this string. I'm in the given formula. So for let's say int I equals to for no la dot length. Okay, so let's assign int I equals to 0 and we'll travel on it till we reach the end. So we have 3 scenarios, right? Let's say char ch equals to formula dot char at I. So if ch is equals to open bracket, then we have to do something. Else if ch is equals to closing one, then we have to do something. And finally else we add it to our map, right? So that's a bit tricky part. So initially we need to understand from till which index we have our element, and till which index we have our number. Alright, so I'll take a starting one and start, because we are starting from this one. From the next index I have to check, right? So I'll do I++, and then we'll start checking. If I is less than n, then only we can keep on checking. And what it should be? That it should be a lowercase, right? If it's a lowercase, we keep on moving forward. So char at I. If it's a lowercase, we keep on moving forward because it will be part of our current element only, right? The moment we come out of it, there could be two possibilities if we have ever entered into this one, if not. But either in both the cases, we'll get our element, right? So it will be nothing but substring starting from start to I. Now we have to check for count. How much is already there? It's for to check to get the element. To get the element. So you have to check the count. Again, we'll do the same thing. So start will be starting from this place. And in this scenario, we don't have to do I++, right? Because here we were starting with the upper letter. So we have to start checking from the next one. But this time, we have already ended the lowercase character. So either it will be a opening one and closing one, or maybe it will number, right? If it's a number, so we have to parse it, right? So I less than equals to n, and if character is digit, if it's a digit, formula dot char at I. If it's a digit, then we have to move the pointer, and if it has ever entered into this one, so we'll get our number. So for that, I should be greater than equals to start. If it's true, then we have to parse, we have to convert the string, right? Substring to number. So it started from start to till I. If not, then we haven't entered into the section, so by default we'll assign the value 1. And now we'll put it to our current map. Current dot map put. What we are putting? We are putting element and current. Let's just keep as current only. Why much to type so much? Current dot get or default element. If not, then 0. Then add. What do we have to add? We have to add the, let's say, count to it, and that's how we'll keep on extracting we'll extract mg, or we'll extract o and its value 1, or maybe o and then 3, and we'll put it into the map. This is done, right? Now we are putting everything to the map. Or if not, if we haven't got any number, it will put by default 1, and we'll end up with I at opening 1. So in the opening one, what we have seen, we have to push the previous map to the stack. So st.push, the current will go to the stack. We'll create a new map. All right. And we'll move forward. And the moment we encountered a closing one, so if we encounter the closing one, we have to get the next multiplier to see if we can have a name multiplier, right? So we can use the same logic which we have used for to get any multiplier. So int start, it will start at I. Again, we have to check for from the next place, right? So we have to check from the next place. I'll do I++, because right now we are standing at closing bracket. So there could be a possibility if something is above, or maybe it's the end. So we have to check if it's not the end. Then we'll try to check if it's a digit. We'll traverse it and we'll format digit. Let's say I'll rename it as multiplier. Multi liar. Multi, okay, let's keep as multi. Now, we have, our current map has O and H and count is 1. And multiplier we got as 2. So we have to update our current map, right? And then we have to push these values into the previous map. It's a bit tricky, so we have to do it very carefully. Let's take a previous map. We'll extract our previous map first from the stack. So previous would be, let's name as previous stack.pop. So this is our previous map. So in this previous map only we have to append it, right? So what we'll do, I'll take string key and current map, right? Current dot key set. So we'll have all the key set, whatever elements this had. And what we'll do in the previous one we only have to update, right? So the previous dot put this key, and if it's already there, so previous dot get or default. If it's already there, then it's well and good. If not, then we'll default it at 0. Then we have to add a current one, right? Current dot get dot key multiplied by, we have to, because in the current one we have to multiply by the multiplier, right? Multi. Right, so this is how it will be pushed into the one, and then finally current will point to previous. Okay, yeah, this is how it should be. Right, so let's say we started from there. When counted 2, we got the number. Then we resolved this section. We got the number, and since if we try to extract the number, our pointer is already at the next bracket or something, so that we don't have to worry. So ideally this should have everything now we have everything in our map. Okay, so in the end my main current map will have everything. So all we have to do is we have to extract them into alphabetical order. So list string, let's say list equals to new array list current dot key set. We'll have all the keys, and we'll do sort it. We'll sort it out. Collections dot sort list. Now I'll start string key k or list. We'll start iterating on it. Let's keep a string builder to append our answer. String builder result goes to new string builder. Alright, so all the key, now whatever elements like this, something it's inside our map. That k is 4, n is 2, oxygen is 1, and something we already have in this map, but we need in ascending order. So we put those things into the list. I sorted it out. Now I'll start iterating so that we can have those things in a very similar fashion. And then it's straightforward, right? Result dot add, or not builder, right? Append. First we have to append the key, right? So it will be k only, and then result dot append the current dot get dot k, right? And I think if we return result dot to string, right? Because it's a string builder, I think we should get our answer, right? Let's try to run it. Okay, we missed something. Oh, right. If its count is k, right? So we don't append it. So if k is not equals to 1, then only we'll append it. Oh, not this. The value shouldn't be equals to 1. So if map dot get k is not equals to 1, then we append it. Oh, sorry, it's not map, it's current. Current dot get k shouldn't be equals to 1 because we don't have to print 1. Then we'll append it. And yeah, it's done, I think. And accepted. That's all.